How does negative feedback stabilize amplifier circuits? Imagine trying to keep a boat steady on rough waters. No matter how choppy the waves, you want the boat to stay balanced. That's similar to what negative feedback does in an amplifier circuit. It helps keep the amplifier's output steady even when things around it change. In simple terms, an amplifier takes a small input signal and makes it bigger. But in real life, the gain, or how much it amplifies, can vary because of manufacturing differences, temperature changes, or aging parts. Without control, these variations can cause the amplifier to behave unpredictably. Negative feedback steps in to fix this. It takes a small part of the output signal and feeds it back to the input but in the opposite phase. This means it subtracts from the input signal, which helps keep the overall output consistent. The way it works mathematically is that the new, or closed loop, gain of the amplifier becomes the original gain divided by 1 plus the product of the original gain and the feedback factor. When this product is large, the gain mostly depends on the feedback network, not the internal parts of the amplifier. This makes the gain very stable and predictable. Negative feedback also reduces distortion, which is when the output signal isn't a perfect copy of the input. It makes the amplifier respond more linearly, so the sound or signal quality improves. Noise or unwanted signals are also decreased because the feedback cancels out some of these disturbances. Another benefit is that it broadens the bandwidth, meaning the amplifier can work well over a wider range of frequencies. It also changes the input and output impedances, usually making the input impedance higher and the output impedance lower. This helps in connecting different circuits and transferring power more efficiently. But there is a catch. If the feedback loop introduces a phase shift of 180 degrees at certain frequencies, it can turn negative feedback into positive feedback, which can cause oscillations or unwanted signals. To prevent this, engineers analyze the loop gain and phase shift using tools like Bode plots and stability criteria. They ensure the gain stays below a certain level at the critical phase shift points. In practical amplifier designs, negative feedback is everywhere. It's used in operational amplifiers, audio systems, and voltage regulators. It helps produce reliable low distortion signals that stay consistent over time. So, in essence, negative feedback acts like a stabilizing force, keeping the amplifier's performance steady and predictable, even when external conditions change.